Hey everyone, so basically in today's GFG POTD we have a problem kth distance. So basically it is an easy level of problem, and the problem given here, given an unsorted array R and a number k which is smaller than the size of the array. Here we need to return true if the array contains any duplicate within k distance throughout the array, else false. That means in the given problem, basically the questions statement is simple. Here we have to here we have a condition that here we have to first of all checks for the duplicates value under the kth distance. Like for example, here we have a example one, and basically in this here we have an array 1 2 3 4 1 2 3 4. Okay, and here we have a kth value or k value which is 3. That means basically k is like representing index value, and if we are like checking from here like 0 1 2 3, okay, then at that position no other elements actually repeating, so here we can simply return false. That means here we have simple explanation that we don't have any duplicates more than kth distance away. Alright, now if you're checking about the second example here, we have the k value as 3. That means the index value. Basically k is representing the index. Okay, so 0 1 2 3. So if we are talking about this thing, so here we can say that 1 is actually repeating twice. So here we can say that true. Basically our task is to return true if any of the elements is repeating under the kth distance, then we need to return true. So here we are actually returning true. So if we're talking about the third example, but before that let's understand the problem here. So basically this is the example 2, and here we have the kth value element as 3. So here if we are like specifying the index, so here it will be like 0 1 2 and 3. So till in this so till from starting, so this position to this position we got 1 as repeating element, so here we have to return true. So for that, first of all, the approach to solve this problem is we need to create a simple map and store all the elements map, because map is basically used to create the elements with their frequencies. So by using map we can solve this problem very easily. Okay, so for that, let's suppose if we are creating a map, then we need to store the element. Like if we can store the element like 1 is like appearing for 2 times, okay, and we need to like traverse till kth position, because here we have a condition that here we need to check whether any array contains any duplicate within the kth distance or not. Okay, so we need to check for kth distance only. So for kth distance we need to check is there any duplicate is inside the array present or not. So here 1 is actually presenting twice, so that means here it has a duplicate. Whereas if you're talking about 2, then it will be like 1, 3 will be again 1. Now sorry, so now what we have to do, like once we take all the values inside the map, then we need to check that which of the elements are having the values more than 1. That means we can simply say that which of the elements are having repetitive values. Then here by simply looking at this thing, we can say that 1 is having value more than 1. So here we can say that 1 is having the duplicates, so we can simply take it as an output. So like if we are talking about, first of all we have to create a map, and first of all we will define the values with the frequency, and let's say if I have to define here MP, okay, for map, then we need to traverse it. Okay, point I is equal to 0, and I will be like traversing to k position, because we need to search for the duplicates value within k distance. Okay, so I is less than k, and then I plus plus. Now we need to first of all we need to store all the elements inside map till kth position. or key index, we can say that. So here we can simply say that MP of array of I and then plus plus. That means we are storing all that means till k position. And now we need to check. That means if array of I, if MP of array of I, that means map of array of I, because we are going to check inside the map, not in the array. Okay, if it is like greater than 1, then here we can simply return true, else we can simply return false. Let's try to compile and run. Okay, so basically here we have now defined I, so here int I is equal to 0. Okay, so the compilation is completed. So basically it is true for example 2 only. Now if you're talking about the example third condition here, so if you're talking about k is equal to 3, that means till k position, that means 0 1 2 3. Actually till this position it is not having any duplicates like 6 8 4 1, but after that it is actually presenting. So we need to also check for the remaining elements also. So for that we have to like for this k position we have like this condition, but for remaining we have to like define for other things. Like here we have to create for int I is equal to k plus 1. That means here we need to traverse for the remaining elements. That means for this example till here we have like traversed, but here we have not traversed. So we can also say that no any other element is presenting or duplicate elements are present for 4 and 5 here. So this condition is like 2 for second example, but if you're talking about the third example, then here 8 is actually repeating. So here 8 is repeated distance 3. So here we need to do for the remaining condition. Okay, so for int I is equal to k plus 1, and here we need to traverse for complete array. So array dot size, and then I plus plus, and then again we have to like do the same thing. That means here we have to first of all create MP of array of I, and here we need to subtract I minus k, that means this position k position, and along with that we have to also like subtract minus 1, and we need to decrement it, and again we have to like MP of array of I, and similarly we have to do increment it. Okay, and then after that we need to check that whether it is having the repetitive here we need to check whether an element is having repetitive elements or not. So here we can say that MP of array of I is equal to 1, is greater than 1, sorry. So here we can say that it will true. Okay, as written false. So let's compile and run. For int I is equal to k plus 1, I is less than array dot size. Okay, so here we have done this mistake, I minus k minus 1. Okay, it will be also k minus 1. Oh sorry, I is equal to k plus 1. Here k plus 1, here we need to do for remaining elements, not from here, and here we have to like initialize I. So I is equal to not I minus. Let's compile and run again. So its compilation is completed. Let's try to submit it. So it's submitted. So that's all for today. Thanks for watching.